Good morning from Turkey and good evening to Malaysia. Welcome to Inter-Islamic Network on Oceanography events on latest developments on marine sciences. I am Bülent Çavaş from Inter-Islamic Network on Oceanography and moderator of this event. I am also secretary of INO. The event is organized by Inter-Islamic Network on Oceanography and contributed by 9 Eylül University, Institute of Marine Sciences and Technology, and University Malaysia, Terengganu, and Faculty of Science and Marine Environment. First of all, thank you very much to every one of you for being here with us today. We have 7 distinguished speakers today. Before starting the event, I'd like to invite INO President Dr. Şermin Açıkçınar to officially open this event, telling us about INO. Dr. Şermin Açıkçınar, please.
Thank you. Dear scientists and participants, on behalf of Inter-Islamic Network on Oceanography, shortly INO, I would like to very welcome to INO event on latest developments on marine science. This is the first important titled event of INO in 2021, and we will continue to do scientific and educational activities in coming months. For that reason, please keep visiting our website and social media accounts to learn more details. I would like to give you brief information what INO is and what are the INO facilities that you can join and get benefit. Inter-Islamic Network on Oceanography is one of the networks of the Organization of Islamic Cooperation's Standing Committee on Scientific and Technological Cooperation for the promotion and cooperation of science and technology activities among the OIC member states. INOC activities include facilities like building effective collaboration in marine research areas in Islamic countries, exchanging information and maintain continuing dialogue in the developments in the field for mutual benefit and use, setting up and maintain data banks on the developments in the subject area for use by the members of the network. Initiating joint projects of research and development of common interest to member countries of the network. As I mentioned, INOC is an educational platform that you can collaborate outstanding researchers who work marine sciences. I would like to thank the researchers of Institute of Marine Sciences and Technology, 9 Eylül University, and Faculty of Science and Marine Environment, and Institute of Oceanography and Environment, University Malaysia, Terengganu, for their contribution to this event where the latest developments in marine sciences will be explained. I will be more than happy to see you in other INOC activities. Thank you for being here with us today.
Thank you very much for your opening speech. Now we can start to the event. I'd like to invite first speaker. The first speaker is Dr. Ong Meng-Chuan. Before presentation, let me give brief information about Dr. Ong Meng-Chuan. He is an associate professor with the Marine Science Program at the Faculty of Science and Marine Environment, University Malaysia, Terengganu. He earned his PhD in marine pollution from University de Paris, France. His field of expertise includes marine pollution, special focus on heavy metals on pollution. Dr. Ong is actively involved in teaching and research as well as knowledge transfer programs to the communities and school children. He is actively engaged in research and form a research interest group, Ocean Pollution and Ecotoxicology Research Group, among UMT researchers and also from other institutions in Malaysia. He is currently mentoring 6 postgraduates who are pursuing their PhD and master degree by research. He has successfully guided 9 postgraduate students as main and co-supervisor until project completion and graduation. He has published more than 70 research outputs in scientific journals and conference papers. He also appointed as Associate Fellow at the Institute of Oceanography and Environment, UMT. Dr. Ong, we are looking forward to listening to you, please.
Okay, thank you, Prof, for your intro. Okay, hello everyone. So briefly, I would like to introduce myself. Okay, I am Ong Meng Chuan. So I'm a senior lecturer in Marine Science program, and also I'm an associate fellow of Institute of Oceanography and Environment, INOS. And I'm also one of the team leaders for the Ocean Pollution and Ecotoxicology Research Group. Okay, from Institümüz. And beside that, I also appointed as a ASM associate in our in Academy of Science Malaysia, ASM. Okay. Just share with you all. So individually we are one drop. So together we are an ocean. Okay. So alone we can do so little. Together we can do so much. That's why we create this group to gather all the researchers in pollution researchers. Okay, doing research in pollution to join this group because when we doing together, so we can do a lot of things actually. Okay, so for your information, OPEC is established in January 2020 last year. Okay, then this group focused on a wide range of research on pure and applied aspects of chemical, biological, physical, and aquatic sciences associated with how humans impact the environment. Okay, and the close collaboration of OPEC research group with other local and international institutions and industries is a key aspect of the success of this group. So for your information, actually in UMT, we have 5 research clusters. So we have ocean science and sustainable environment, we have food security, we have data and digital sciences, we have science and marine engineering and technologies, and also maritime and communities science. Okay, so OPEC is under ocean science and sustainable environment, so lead by Professor Dr. Norayan Haji Mota. She is our leader for this cluster group. Okay, so what the mission of OPEC? So OPEC, we want to empower marine and aquatic resource-based research through robust research networks with national and international collaborators for global sustainability. This is our mission. Okay, and just share with you all, this is our expertise in our research group. So mainly we in marine pollution or in metals pollution, in ecotoxicology, marine environmentometry, microplastic, and also ballast water pollution, and so on. Okay, this is the field that our research group can cover for this time being. Okay. Okay. So till now we have about 29 researchers from UMT to join this group, and we have about 13 researchers from Malaysian institution, which cover other university in Malaysia, okay, government and also non-government university, and also other research institute. Okay, and beside that, we also have around 28 researchers from international institutions, mainly come from Indonesia, Thailand, Vietnam, Philippines, Hong Kong. Okay, and also we also collaborate with industry partner. So far we have 5 industry partners to work with our group. Okay, this is some of the Malaysian institutions that in our group. So we have all the I can say that almost all the Malaysian university, government university in Malaysia that collaborate with our group. Okay, and this also these are the international institutions, and we work very closely with University of Hong Kong, City University of Hong Kong, the Hong Kong Polytechnic University, also the Education University of Hong Kong. Okay, so beside that, we also work closely with NUS, National University of Singapore, and IPB, University Tanian Bogo, okay, and Prince Songkar University, PSU. Okay, this is what our close collaborator actually. Okay, and beside that, we also collaborate with some in Philippines, also in Vietnam, and we hope to to have Enoch and also Docus LU University to join our research group for the future. Okay. So this is some of the industrial partner in our group. So we have for the fisheries department and for the nuclear Malaysia. This nuclear Malaysia, they help us to detect all the sample for the radioactivity. For example, like to do the sedimentation analysis and so on. And the IMR is more to like we collaborate in how to estimate the impact of the pollutant toward human. Okay. So this is some of the research expedition that we conducted in last year. Okay, so we focus around the island in Terengganu. Okay, and we use our research vessel UMT RV Discovery. So this is one of I can say this one of the high-end vessel that we can find in Malaysia for research purpose. Okay, so far actually this research already travel around Peninsular Malaysia from southern to northern of Malaysia. Okay, and last year this is the group that participate in the research expedition on board. Besides that, we also have several researchers that participate in the lab. Okay, so here we have about 8 researchers, and we also have 3 technical supporting staff to help us for the sampling activities. So in this expedition, we spent about 4 days, 3 nights. Okay, and we obtain all the sample for the biological analysis, the chemical analysis, the physical analysis, also the geological analysis. So we are looking forward for new research collaboration to join our research group. Okay, so of course we cannot do everything. Okay, so we need other researcher or friends to fill in the gap where we cannot do the not in our field actually. Okay, so as mentioned by our head of cluster, so I assume that our research group is like connecting the dot between the researchers. Okay, for example, UMT researchers with the Enoch researchers. So we are only connecting the dot. So we hope that with this connected dot, we hope we can expand all the research activities. For example, like we have the we can organize expedition together. Okay, and we can do a lot of things actually with the collaboration. Okay. So this is some of the collaboration I think we can conduct it. Okay, we can have a joint publication, and we can join a research grant. Okay, and also we can have the student supervision, for example, for the master, also the PhD. And then beside that, we also can become a thesis examiner. Okay, and also we can like suggest the researcher as a journal reviewer. Okay, for the journal and so on, articles, journals, or book in chapter in books and so on. Okay, so this is our research group website. Okay, so you can visit the website. Just type OPEC at UMT, so you can go to the website, and we have some information about the OPEC, the researchers, or the field of the researchers inside the website. So maybe other researchers can go to the website and they can look for the potential collaborator. Okay. And okay, this you can find also this one in the website, just some information, and anything you just can contact me for further information, just email me and so on. Okay. And I think I can promote here. So actually our group, we have a virtual ocean pollution ecotoxicology symposium, OPEC, next year, 1st and 2nd March next year. So we hope that some of the researchers from Turkey can join us in the conference. It's 100% virtual conference. Okay, So the information we will upload in the website also. Okay, so take home message. Okay, so we are not restore the marine environment to normal condition. Okay, but actually we create a new marine environment. That's why now actually, if you want to restore the marine environment to zero to original condition, if for me I think it's not really we cannot do it. But actually we are now create a new marine environment. We are live in a new marine environment. I think it's the same with the pandemic COVID now. We live in a new normal. Okay, so we live with the virus actually now in our society, in our environment, and so on. Okay, so if you want to go fast, you go alone, and if you want to go far, we go together. Okay. Okay, so thank you for your attention.
Thank you very much, Dr. Ong, for your very useful information about your research group, OPEC, and conference you will organize next year, and also important messages, especially for opportunities for further collaboration between two countries. Thank you very much for your presentation once again. So I'd like to invite second presenter. He is Associate Professor Dr. Saifullah Arifin Din Jaman. Before his presentation, I'd like to give you information about his bio. He received his bachelor degree in fisheries science from University Putra, Malaysia, Master of Science in Marine and Fisheries Science, and his Doctor of Philosophy in Zoology from University of Aberdeen, United Kingdom. He is qualified marine mammal observer and certified Department of Environment, Malaysia, subject consultant on marine mammal. Dr. Jaman has presented papers at international conferences in Europe and Asia, and has published a monograph and more than 20 articles on marine mammals in Malaysia. Dr. Jaman teaches biology and marine vertebrate at the School of Marine Science and Environment, UMT, and conservation of marine endangered species for the EC-funded Erasmus Mundus Master's course in tropical biodiversity and ecosystem. He had supervised 12 graduate master students, and he is currently supervising 1 PhD and 7 master students. Yes, Dr. Jaman, we will be more than happy to listen you. Dr. Jaman? We cannot hear you.
Oh, sorry. Okay.
Yes, we hear
Hello,
you.
and good afternoon, ladies and gentlemen. Thank you very much, Professor. What I would like to share today is actually on one of our work, our Marine Endangered Species Program work in the Bay of Brunei. This is one of the sites that we have research on marine mammals in Malaysia. This is to show you where is the Bay of Brunei. You know the island of Borneo. As you can see here, there is a small bay here. So this is where the Bay of Brunei. It is actually named as the Bay of Brunei, but 70% of the area is actually in Malaysian waters. So only 30% of that bay is in Brunei waters. It is a deep bay and sheltered from the South China Sea condition, and it is a natural port for the maritime and petroleum industry. Why we choose this Bay of Brunei? It's very nice. It consists of unique marine ecosystem They have mangrove forest there, large estuarine, seagrass bed, mudflat. As you can see here, many of the areas are actually pristine mangrove forests in the Bay of Brunei. But at the same time, we have many fishing villages along the coast. And it is also very high diversity of fauna and flora in that bay. And it's an important nursery, feeding and transient ground for dugong, turtle, dolphin, commercial fishes and shrimp and seabirds. Like I told you, is a mangrove rich ecosystem and has a high fisheries productivity in that bay. At the same time, the bay is also used as a natural seaport for the maritime and Brunei petroleum industry. So they are part of the bay that has been developed. This Labuan Island, you see here, is actually developed as a support base for the Brunei petroleum industry. They have a petroleum refinery center here, there, and then they have ferry and speedboat services to go from the mainland to the island. And this Brunei Bay is less exploited, but the bay and this marine endangered species is facing multiple stresses from climatic change, pollution, land reclamation, ship navigation, and fishing in the area. As we can see here for seagrass, we have 9 species of seagrass in the bay, which is the highest number of seagrass species in an area in Malaysia, where halufula and haludule are the dominant species. Okay, and this seagrass has monthly changes percentage cover. Their monthly changes percentage cover actually are significant because of the different season. The changes correlate significantly with turbidity measurement, and weather changes always affected the seagrass population. You can see some of the species of seagrass in that Bay of Brunei. I want to show you the result of our marine mammal survey in that bay, either in Malaysia or in Brunei Darussalam. We have actually known 5 species of marine mammals there: Irrawaddy dolphin, the dugong, the Indo-Pacific humpback dolphin, the Indo-Pacific Botanus dolphin, and the finless porpoise. This is the most common species of dolphin found in the Bay of Brunei. It's Irrawaddy dolphin. It's not a species that you can find in Turkey, probably, but this is the most common coastal dolphin species in Southeast Asia. We have surveyed the whole of the bay, and those dolphins are near to the coast, not more than 5 kilometers offshore from the beach, and they are concentrated in many of the calm area of the bay. So usually Irrawaddy dolphin will always be very near to the coast, like this. Not data, but previously we had already 145 sightings. The overall sighting rate is high, about 0.3 per 100 kilometer hours. And this sighting rate is highly significantly different between the regions. So between the areas of the Brunei Bay, you will see that these Irrawaddy dolphin are actually more concentrated in the Brunei waters. And this sighting rate is not statistically different between seasons. So that means species is always there in the Bay of Brunei, all year round. Some of the activities of Irrawaddy dolphin, they are very, they are considered shy. But in Brunei Bay, you will see Irrawaddy dolphin will come and feed very near to the fishing vessel, fishing boat, because normally fishermen in the Bay of Brunei, they like to throw out the fish, the trash fish, which they know that this Irrawaddy dolphin will eat. So Irrawaddy dolphin will come very near to the boat, and fishermen will feed them with the trash fishes. And they also do many exciting behavior like water spitting. This is actually one of the behavior that they try to group fishes in the area so that they can feed easily. Okay. They do group traveling. They cross very often from the Malaysian side to the Brunei side, and they go from one place to another place. Depends on fish in the area. Okay, you can have once you spot an Irrawaddy dolphin group in the Bay of Brunei, it's easily to follow them, and it's easy to take photo and also to record the behavioral activity of that dolphin. So for summary, for this dolphin, the mean group size is quite high, actually 6.4, and this mean group size is significantly different between region. In some of the area, there are many in one group. Other area, there are not so many, and about 36% of the sighting, we will see calf within the bay, within the group. So that means that the population is good and increasing. And Lawas has the highest mean group size and the highest number of animals that we have counted in the group, which is 35. And this mean group size is not statistically different between season, meaning they are always in that group for the whole year. But in Brunei, the mean group size is significantly higher during the northeast monsoon. So that is the area where they will go during the rough northeast monsoon. So Irrawaddy dolphins are found to be distributed all over the area and as far as in the river, like in the Temburong and Pandan estuary. And they may prefer the Bruneian side of the bay for their daily activity because it's relatively sheltered and contain a number of islands and large estuary, mangrove forests and mudflat as compared to the Malaysian side. We have done photo ID for Irrawaddy dolphin in the Malaysian side, and we have counted about 47 the number of Irrawaddy dolphin, estimated about 47 of Irrawaddy dolphin in our Malaysian side. The next species that we have in the Bay of Brunei is the Indo-Pacific Humpback dolphin. This is also a Southeast an Asian species. I don't think you have this in Turkey. It's a coastal dolphin, generally staying within a few miles of the shore and preferring water less than 20 meters. And this dolphin is also like Irrawaddy dolphin. Sometimes you will see them swimming into the river. These dolphins are more acrobatic. They like to show off better than the Irrawaddy dolphin, as you can see here. And sometimes they will jump out, and you will get to get photos, good photos of them, you know. And in the Bay of Brunei, positive interaction between Indo-Pacific humpback and Irrawaddy dolphin are always recorded. They like to hunt, and sometimes they like to swim in the same group, two species in the same group. Okay. So we have mixed species group of Irrawaddy and Indo-Pacific humpback dolphin in the Bay of Brunei. You will see that the front dolphin is Indo-Pacific humpback, this one, and this is Irrawaddy. The next dolphin we have there is Indo-Pacific Botanus dolphin. This is another species after the common Botanus dolphin, and this dolphin live in group that can number in hundreds. But groups of about 15 dolphins are common, and they are there in the Bay of Brunei. This is observed very near to the coast near to the awat. And the last citation that we have in the Bay of Brunei is the finless porpoise. This is very shy citation. They looks like Irrawaddy dolphin, but the size is a little bit smaller, and they are lack of dorsal fin. So that's why it is called finless porpoise. Usually when you see them, it's very difficult for you to get photos of finless porpoise. So the photos I have at the moment is only the one in captivity. This is not from Brunei Bay. And last but not least, most importantly, dugong are known to feed and take refuge in the Bay of Brunei. So this is dugong because there are lots of seagrass meadow in the bay, so dugong are there. And sadly, dugong also are found dead in the Bay of Brunei. There are many causes of mortality, like fishing, tangled in fishing gear, or they got knocked by boat or vessel. And before, I mean, many years before, we used to use a small Cessna to go out and study dugong in the area. But nowadays, we are using drone to do that. And you will see that dugong are actually, the distribution of dugong in the bay are actually distributed based on seagrass meadow in the bay. So you will see dugong in the bay when they come in during high tide to feed. And by using more good method like using drone, we can count more and more dugong now. And the good thing about dugong in the Brunei Bay, every time we get to photo them, we get a photo of mother and calf. So we know that the population there in Brunei Bay are actually reproducing. So far, we have seen dugong when they come in to feed on the seagrass, and the group size is about 2.4. Usually we will find only single dugong, but several times we have seen a maximum of 8 dugong in one day survey. So this is quite a viable breeding population with a minimum of 18, which consist of at least one mother and calf in the bay. Okay. So like I told you just now, why there are dugong in the Bay of Brunei, because of the relationship of dugong and seagrass. This is the only food of dugong, the seagrass, and you can see dugong feeding trail. When during low tide, if you go on the seagrass, you will see a lot of dugong feeding trail there. Okay, and even though you don't get to see dugong many times, but you know they are there from the feeding trail. And this dugong feeding trail on haludule species 10 with evidence of task marking on the bottom sediment. Okay, so as a conclusion, the Bay of Brunei is an important habitat for a significant population of marine mammals, particularly the resident Irrawaddy dolphin. Irrawaddy dolphin had been observed to travel along the coastline of Labuan to Lawas in the Malaysian Bay of Brunei, and to swim across and take refuge in the water of the Brunei Darussalam. Mother and calf group up, and positive interaction between Irrawaddy and Indo-Pacific humpback dolphin are commonly observed. And these studies here now in the Bay of Brunei, studies on coastal dolphin and other marine endangered species like dugong and turtles and their habitat like seagrass and mangrove has been continued using more advanced method, like we use UAV or satellite radio telemetry, bioacoustic, genetic and biopsy sampling through some international collaboration, like in China, by using the China Southeast Asian countries marine cooperation platform. Thank you very much.
Dr. Jamal, thank you very much for your presentation and information and latest developments on dolphin science. I'd like to invite the next presenter and speaker. He is Harun Güçlüsoy. Before his presentation, I'd like to inform him. I would like to inform you about him. He received bachelor and master degree from Middle East Technical University, Department of Biology from Turkey. Dr. Güçlüsoy did his PhD on marine living resources at the 9 Eylül University, Institute of Marine Sciences and Technology. He is still working at the Institute of Marine Sciences and Technology as an associate professor. His main research interests are marine conservation, in particular marine mammal science and management, marine protected areas, and integrated coastal zone management. Dr. Güçlüsoy, may I invite you to start your presentation, please?
Thank you, Mr. Chair. Thank you very much for inviting me for this very important event and also refreshing all ENOC activities. I'm very delighted to be on board again with this occasion. So also thank you very much for both presenters, for OPEC and Marine Mammals of Malaysia. So I was very enjoying going far to east side of the globe and being in Asia for some time. So I would like to take the attention of all colleagues and also presenters as well as the participants not back to, but mid of the globe, which is Mediterranean. So, but while Romans were saying that is the center of the world. Anyway, so well we are. I'd like to talk about the Mediterranean monk seal. This is the only seal species in the Mediterranean, and it used to be thought that both these species as well as the congener Caribbean and Hawaiian monk seals were in the same family or even a subfamily, but it's with the genetic resources it's found out that it's not the case anymore. So Mediterranean monk seal is a subfamily as itself. So it's so pristine animal, and as far as I understand from a previous presenter, Dr. Jamal, as far as I remember his name, sorry if I made a mistake, that there is no pinnipeds in your bay, and this is the only pinniped we have in the Mediterranean monk seal. And even during Roman period, it was so few in numbers that the skin of the animal was sold as 1,000 denarii, whereas all the leopards and pars were sold only 50 denarii. So you can even infer from this information that how rare the animal was during the Roman period. So not only the animal itself is also very nice looking, it's also where they are living is so pristine, as you can see in the south coast of the Aegean, where all these red pine forests are meeting to pristine waters of the Aegean, and where they are residing in the coastal caves, these monk seals. So when we look at the numbers globally, it's expected that, well, it's estimated that it's around 450 major individuals living globally, and the main population is being in the Aegean of the Mediterranean Sea. Plus, there are some remnants population left also in the North Atlantic, in Madeira Islands of Portugal, as well as Mauritania. And even in the north of Mauritania, which is called Western Sahara, which is still debutable land, I must say. So around 300 individuals in a colony formation, they are living in that area. But one of the major problems with the monk seals were low genetic diversity. So there are not so many populations actually. So even in the Aegean, only 2 populations, and in the Atlantic, only 1 population, we can say, according to genetic studies. So, come as a breaking news, when I was showing all these pristine bays and beautiful animals, and last 10 days, what happened in the Aegean, where you can see on the left, unfortunately, southwest coast, all pine forests were now set on fire, and it's because of well, I think because of man-made problems, but we don't know the exact cause. So, therefore, all these pristine coasts maybe will no longer be with a lot of forests on the coastal caves for the monk seals. and we hope that they will be again keep them as a forest rather than having secondary housing or holiday resorts in the future. And when we go to the other side of the Aegean and the Greece, and rehabilitated monk seal unfortunately found dead 7 days ago. This is one of the other reasons of the species declining numbers, is that it was speared by most probably a fisherman from a boat, and unfortunately found dead. So that was a big news globally also, and it was a sad situation. So if we sum up all the threats actually from higher risk to lower risk, you can see habitat is the main challenge for the seals. For example, on the left bottom corner, a monk seal cave, and on top of it is a house built upon, and this cave is still in use. So I mean, these kind of activities should be, if possible, avoided so as to leave species some space. The space is the main challenge now globally for all habitats, ecosystems, and we should respect the space of all these of the other species rather than man, I must say. So there are nice documentaries recently also for the habitats. And the least one is the low fecundity top survival rate due to inbreeding stress, since there is only few population left. So when we come to the marine mammals of the Aegean Sea, I will not only talk about the monk seals that we have, but I will just briefly explain how many species basically we have as residing animals, like sperm whale, for example. One of them is in the Hellenic Trench, or a trench between Asia, between Turkey and Greece. And Ziphius capristris is the cuvier beaked whale, and grampus, and bottlenose dolphin, striped dolphin, and also common dolphin, as well as very few remnant populations coming from Black Sea is the harbor porpoises we have also as cetaceans, and the Mediterranean monk seal, of course. So with the Institute, what we are doing regarding the monk seal as well as the cetacean research is we can give them the two main items. One of them is having projects and to do projects on the Aegean, of both including monitoring, photo ID, population distribution, and the other one is the graduate thesis, like on fisheries interactions, trendings, photo IDs, platform of opportunities were in use also sometimes when it's possible, and also even innovative approaches, which I will explain a bit later. So these are only two points explaining about these bottlenose dolphin in Foça Special Protection Area. This was done in 2014 and 15. We identified only 11 animals, but this study should be continued with the dorsal fins. So it was a very brief survey, actually, only one season. So we would like to continue with this study. Another one is in the north of Aegean, in the Çandarlı Bay. We did some surveys on cetaceans again, their distribution and abundance, and mainly we found in these bays is the very few, 1 or 2 sightings actually, common dolphin, and the other one is bottlenose dolphins, mainly residing in the area, and we can say that even resident in this highly industrial zone. So regarding monk seals work, what we do is that we basically have 5 actions to do where we are going. It's like mapping, surveying the area, and mapping where the suitable monk seal caves are located, and plus installing some cameras, photo cameras, of course, photo traps that we don't need to go too many times in the caves, not to give any disturbance to the animals. And collection of genetic samples, if possible, from remnants of furs, for example, or feces, and development of a photo ID catalog, and collection of sighting data also, since there are so few in numbers now. We need to also collect each sighting information from the fishermen as well as the sea-dwelling people on the sites. So on the Aegean Sea, for example, we have identified some caves here. Again, as a monitoring study, we installed the cameras in the coastal caves, and And we try to collect every 4 months or 3 months with this is a Bushnell trap, as far as I remember. So try to collect all the monk seal used in the caves. While we're using these camera traps or video recordings, you will see a bit later, we always use infrared light source, so as not to give any disturbance to the animals if possible. So basically, they recognize the camera is being there, but it seems that they are not very much disturbed. So these kind of tables, for example, for example, from this study, we collected almost 45,000 pictures, and then it was all go through, and then how many animals were seen in the area. We are just collecting. So this is the last study that we are doing with my PhD student, Ezgi, and in Gökova Sepa, as another monk seal site, a very important monk seal site, and we even develop systems now, not only photo camera systems, but we now use 4K video recording systems inside the caves, so that even we get the energy from solar panels and then we use the electricity without interruption, and all this can be followed online. So whenever we want, we can go in online and see if there are any animals using the site. So, for example, this is one shot from last September. 2 females inside the cave, and the one on the top is adult one, and the other one is a bit younger compared to that one. And what we are basically do for photo ID, we just collect information, especially with the deep scars, or if there are any coloration pattern. Then we try to use these features of the animals to photo identify. For example, in this bay, we identified more or less 11 animals, 2 being male, 6 being female, and the rest we don't know yet. Whether it's a young animal will be a male or female in the future, that we don't know much. So let me go this. And females are getting mature like at the age of 4, and males are getting mature at the age of 7. And every alternate year they give birth for 1 pup. So they're basically very slow in terms of breeding, I must say. Even lazy, maybe it's just a bit Mediterranean flavor, being lazy also. Although some conditions are still optimum, they are not breeding. So this is what was found also in the Atlantic population. All right, move on. As I said, also we collect some sighting information. This is the information we collected for this 200 nautical mile coastline, from both fishermen as well as sea-dwelling people, and this was not normalized yet, because we need to find also the activities of these people seasonally or even monthly if possible, so as to normalize this data. But still, we need to continue with this PhD study, and then once we finalize, then I'm sure we will know the hotspots where the human activities are overlaying or overlapping with the monk seal presence in these sites, so as to propose some core zones for protection or buffer zones. And before 2 last slides, this is one of the innovative work that we've done together with Mediterranean Conservation Society, where my PhD student works. This is one of the coastal caves where it doesn't have any platform inside. We made an artificial platform or ledge inside cave so that monk seals can use it. And after being constructed, these monk seals start using after 4 months later. So they can easily find in the areas monk seals, these kind of areas, so that they can be in use. So final word for the seals. I'm no longer talk, and let them hear, and then we'll finalize the presentation. Thank you for listening.
Dr. Ddt, thank you very much for your very interesting presentation about monk seals and dolphins. I believe that these presentations will create further collaboration between 2 countries. Thank you once again for your very interesting presentation. I'd like to invite next presenters, who is Tuan Muhammad Fauzan bin Tuan Omar. Before his presentation, I'd like to give you information about him. He is currently a senior lecturer in Marine Science Program, Faculty of Science and Marine Environment, University Malaysia, Terengganu. He earned his bachelor degree on Analytical and Environmental Chemistry from University Malaysia, Terengganu, master degree from University Sains Malaysia, and PhD in Environmental Quality and Conservation from University Putra, Malaysia. His research interest is on the analytical and environmental chemistry, special focus on the analytical method development using high-end instrumentation techniques such as gas chromatography, mass spectrometry, liquid chromatography, mass spectrometry, inductively coupled plasma mass spectrometry, and various other instrumentation techniques. He has wide experience in analyzing contaminants in food and environmental matrices. His latest research is on the assessment of distribution and fate of emerging organic contaminants in marine and coastal ecosystem, and the possible risk to the ecological as well as human health. Dr. Omar, I'd like to invite you to start your presentation.
Okay, Assalamu alaikum, and good day to all. Okay, so the title of my presentation today is Profiling Emerging Organic Pollutant Contamination in Malaysian Coastal and Estuarine Ecosystem. Actually, this topic will be focusing on the Klang River estuary, not the whole Malaysian. So basically, because Malaysia is we have two, East Malaysia and West Malaysia. So basically, Klang River estuary is situated at the Peninsular Malaysia, or we call it as West Malaysia. Okay, like the Saifullah show is in the Borneo Island. So that one is also in Malaysia, but it's in the Borneo Island. Okay. Okay, the scope of my presentations today, basically I will talk about the analytical methods. So because I'm trained as an analytical chemist, so it is my interest as also a environmental chemist to develop methods whereby in the biochem matrices or in the water matrices or in the sediment matrices. So it is my interest to develop a method for that, and then also the second scope is the occurrence and distributions. I will talk a little bit on the occurrence and distribution, and lastly followed by the risk assessment. Okay, I'm sure that some of you a little bit familiar with emerging organic contaminants, but let me refresh. So EOC refers to a group of new substance, okay, which no maximum levels have been laid down by any legislation or regulation, and it also compound that previously identified but need revision on the maximum level. So there is if there is a new toxicological input or data or scientific evidence that the compound have an effect to the humans, then they review revise the maximum levels. Okay, and then because of their ubiquitous presence in the environment and their ability to interfere the hormonal system, then that's why we need to have a good data or database on these contaminants. Okay, and then earlier study on the EOCs published by Sumter and Jobling way back in 1995 found that there is a intersect changes and sexual disruption in fish. Okay, and then this will causing the possible reduction of fish populations in the ecosystems. Okay, and then European Food Safety Authority have been active in revise all scientific data to actually revise the maximum level. Okay. Okay, common EOC found in the metal matrices we can found in the sunscreen and lotions. So be careful when you use the sunscreen and lotions. It might affect the ecosystem. So compounds such as triclosans, DDET. So we have also in flame retardants, okay, plasticizer, BPA, phthalates, okay, pharmaceutical active compounds such as diclofenac, primidone, and the list goes on. Okay, okay. This is the source of EOCs in the environments. It can be from the wastewater treatment plants. It can be from landfill, municipal waste disposal sites, and it goes into the environmental matrices such as sediment, water, surface water, and also lastly it goes to the biota. Okay, one of the EOC that gain significant attention is contraceptive hormones. Okay, the compound is ethinyl estradiol, and European Commissions has proposed limiting the levels of contraceptive hormones in the surface water, particularly in ethinyl estradiol. Okay, so they want to propose maximum levels on these compounds. Okay, and then we can see the rise of the sea fish. So that's the create ecological unbalance. Okay, current update on the EOCs. This is not a latest. I found because the EOCs have been studied widely, even in Malaysia. So I can see that not really an update list, but we can say that it is a pictures on the research going on in the Malaysian ecosystems. Okay. All right. So when we want to analyze the samples, so we have to deal with the challenges, especially in the on the methods. So actually, we have to develop a very robust method, very good methods, in order for us to do the analysis in sediment matrices, in surface water. We have to get good methods and proven method that we can use for the monitoring. Otherwise, our result will be questionable. Okay, so we must have very good recoveries, all those things for the analytical parameters. Okay, I will talk a little bit on this later on. Okay, so we move on the current trends on instrumentation technique. So as we can see that we have a few methods or few instrumentation technique to analyze the EOCs. So we have the LCMS, we have the GCMS, we have the HPLC with DAD of FLD, and also we have the LC HRMS. This is the high-end instrumentation technique. But then we found that most of the compound mostly developed for the LCMS-MS. So that's why for this study, for this project, we decide to use the LCMS as our instrumentation technique. Okay. All right, analytical strategies, output and outcome of EOC. Like I mentioned before, so the analytical method is an important part of the projects. I can say, of the project, because this part we have to really develop a methods to quantify the EOC at the trace levels. So if you cannot get the good methods, and then we cannot quantify at the trace levels. Okay, and then after we got the done the analytical methods, and then after that we can do the monitoring, detection, and quantifications. And also lastly, we want the main objective is to safeguard of the environment and humans from what we get from our data. Okay, a little bit on the research framework. I just want to show that the objective of this project is actually optimization of analytical method, occurrence levels, distribution pattern, and lastly, we want to analyze the environmental and human health risks. So this is the matrices that we collect. Okay, we have a water, sediment, and biota. Okay. All right. So this is basically geographical setting of our sampling sites. Okay. So this is a Peninsula Malaysia. If you're not familiar with the geographical setting of Malaysia, we have two, like I mentioned before, we have a Peninsula Malaysia and East Malaysia in the Borneo Islands. So Dr. Saifullah has already shown you. Okay, so this is a Klang River estuary. So why we want to study the Klang River estuary? Okay, so mainly because of this river receiving pollution lot. Okay, this estuary receiving pollution lot mainly from Klang River and Langat River. Right, and then it is a house for busiest commercial port in Peninsular Malaysia. Okay, we have Port Klang Complex. So many industrial establishment we can found here. Okay, all right, surrounded by various industrial and aquaculture. Okay, and then habitat for various commercial seafood products. Okay, we can find that various fish species here, clam, mollusk, and also cockle. Okay. All right. So I show you some of the our activity for sampling. This is for water samples. We did on the in situ pH, temperature, EC, salinity, DO, and then we have total organic carbon. Okay, and then we adjust the pH of water samples into two with hydrochloric acids. So this is basically for sediments. Using the Ekman grad sampler to collect the samples, okay, homogenize the transfer into methanol rinse ambient glass bottles. All right, so this is for sediments, and this is for biota. So we have two type of biota. We have fish. So fish that we collect is a sea catfish and a croaker. So Aries taradicinus and Panahia enia. And also we collect mangrove snail, Nerita lineata. Okay, and then we did an pre-treatment for the samples. Okay, just as mentioned before, so LCMS is chosen for this analysis for this project because of one is it is a very good instruments, and then we can do simultaneous analysis, like we can analyze 16 compounds using the LCMS MS analysis. So back then we have to optimize the LCMS MS so that we can get a very good instrumentation setup. Okay, so this is a compound optimizations. We did the compound optimizations. Okay, so we optimize for DP, disclosed string potential, all those parameters for LCMS. Okay, and then for further reading, you can actually look into these journals for the details of further readings of this how we develop the methods for this one. Okay, and then we have optimization for water samples. Okay, sediment samples. Okay, this is what we did for the sediment samples and also for the biota samples. So all what we optimize here, basically we got a recovery percentage around 70 plus something. Okay, actually except for the biota because of this is challenging metrics. So I think we got about 60% of recoveries. Okay, right, that's all for the methods. Okay, and when we move on to the occurrence, okay, the levels and occurrence of EOC in the estuarine water. So basically we developed for 16 compounds. Okay, for 16 compounds using the LCMS. And then for estuarine water samples, we only detect 10 compounds. Okay, so we only detect 10 compounds in the Klang River estuary. So we found that bisphenol A having highest concentrations or levels around 500 something nanogram per liter. And also we found that antibiotics, amoxicillin. So as amoxicillin is actually commonly prescribed antibiotics at the government healthcare facilities. You can find it in the anyway antibiotics, amoxicillins. So we usually government healthcare facilities provide these amoxicillins to the patients. And also we found that diclofenac, commonly found pharmaceutical compounds, also supplied by the government healthcare facilities. All right, and then in sediments, okay, we have another one compounds. So like estuarine water sample, we have 10. So we found that 11 compounds were detected in the estuarine sediments. So again, we found that bisphenol A having the highest concentrations. Okay, and then followed by diclofenac. All right, for the biota samples, so we have for fish samples, so we found that 10 compounds were detected in Aedes thalassinus. Okay, so this time we found that diclofenac. So diclofenac having the highest concentrations. Okay, and then followed by bisphenol A. Okay, the same pattern also happened in the big eye croaker or Penahia ania. So this time we also found diclofenac having the highest concentrations. All right. All right. How about the mangrove snails, Nerita niliata? So in this biota, we found 10 EOC. Okay. And then this time we found progesterones. Okay, having the highest concentrations or levels. Right. And then we found that the sampling point that we collect these mangrove snails is at the river mouth of Klang River estuary. All right. So moving on to the environmental risk assessments. So this environmental risk assessment or ERA is calculated based on the concentration of water samples. Okay, from the water that we collect, we did some calculations to come up with the risk assessments. So from our results, we can say that most of the compound is at the low risk, except for the bisphenol A. Okay, so we have a medium risk or moderate risk for the bisphenol A. Okay, all right, and then we move on to the health risk assessments. So this is based on the biotar samples that we collect, but then we have limitation here because not all the compound have a toxicity data. So we only managed to do the for the 3 compounds, diclofenac, progesterone, and BPA. Okay, so all the risk assessment is below 1, so indicating that it is still safe levels for the risk assessment in the Klang River estuary. Okay, then we compare with the study, the worldwide study on the risk assessments, and then we found that some of the countries or sampling areas such as in South China have a high risk for erythromycins. Even in Klang River estuary, we can see the Kashaffazivat or Takabulosani. Okay, this guy did on the polyaromatic hydrocarbons and then found that high risk of polyaromatic hydrocarbons in this estuary. Right. So for conclusion, okay, we can say that prevalent concentration of EOC, okay, particularly BPA and pharmaceutical compounds, okay, presence in the environmental matrices and biotar sample from Klang River estuary, and also this targeted compounds showed a low risk, only for the BPA having a moderate risk. Okay, moving on for the future, I think we need to really look into the all across the Peninsular Malaysia to do monitoring, especially in the east coast of Peninsular Malaysia, because not many studies have been done on this part of Peninsular Malaysia. Okay, all right. Some of the selected publications. If you want to have a further reading on what I discussed here today, you can look into these publications. Okay. All right. Okay. This is sampling activity. Dr. Ong already showed our RB Discovery Scientific Stations before. So I just end my presentation today with a quote from the Henry Ford: "Coming together is a beginning, staying together is a progress, and working together is a success." That's all, Prof. Terima kasih. Thank you.
Thank you very much for your presentation and final message to all of us. And very thanks once again for your very interesting presentation. And we learned lots of things about chemical science of marine science. Thanks once again. I'd like to invite the next presenter. He is Tolga Gönül. Before starting his presentation, I'd like to give you brief information about him. He received bachelor degree from Ege University, Faculty of Science, Department of Chemistry. He has a master degree from 9 Eylül University, Institute of Marine Sciences and Technology, Department of Sea Chemistry, and PhD degree from same institute, but Department of Coastal Engineering. He is still working at the Institute of Marine Sciences and Technology as associate professor. His main research interest fields are marine chemistry, environmental chemistry, marine pollution, metals, organometallics, metalloids, polycyclic aromatic hydrocarbons, and persistent organic pollutions, in marine sediment and biota, oil pollution, and its effect on marine life, nutrients, and in the marine environment, evaluation and eutrophication, and determination of ecological quality status, ecological risk assessment. Dr. Gönül, we will be happy to listen to your presentation.
Hello to everyone. My name is Tolga. I'm working on marine chemistry program. I'm originally a chemist. It's a pleasure to be with you here. I live in Izmir. Here is Izmir. You see in the map of Turkey. First of all, I would like to show you our institute research vessel and marine chemistry lab very quickly. Here is our institution. It's the picture. Here is the picture. This picture belongs to Kocaeli Reefs, our research vessel. The ship we use for cruises and field studies, especially when we go sampling. I want to show you quickly. In our, I had been working for monitoring studies. I used to collect sediment samples by box scorer and used to catch the fish by trawling. We analyzed three matrices: seawater, sediment, and biota. Here is the marine chemistry lab. This is a list of devices we use. You know, GCMS, GCECD, auto analyzer, atomic absorption spectrometers, and etc. Our sample preparation rooms, Soxelet apparatus, freeze dryer devices, our research bench, spectrophotometer. We use Scala Sun++ auto analyzer to measure nutrients in seawater. Variant atomic absorption spectrometer, GCMS and GCFID systems. And as for the emerging contaminants, I want to give you a short definition. Emerging does not mean that these chemicals are new. These chemicals have been released into the environment as long as they have been in use. Organic chemicals, we focus in this presentation and our research mainly organic contaminants. We analyze organochlorinated pesticides, PCBs, and pH compounds here. They are not commonly monitored, demonstrate to occur in the environment, believed to have the potential to create an ecosystem for human health risk. Suspected endocrine disruptor compounds, we call them, metals, personal care products, pesticides, pharmaceutical drugs, synthetic and natural occurring hormones, and include this group, industrial chemicals. As a synthetic compounds, agricultural compounds, we measure organochlorine pesticides and phenolics, bisphenol A, as Tuan said before, flame retardants, phthalate plasticizers, PCBs, and PAs. In our studies, it has been 16 or 17 years since I came here. With this time, we measured PCBs, PAs, and metals, organometals in our laboratory, in our institution. As a pollutants for Turkish shoreline is due major land-based sources such as untreated wastewater from domestic and industrial settlements, pollutants brought from inland areas by rivers, coastal agricultural practices, tourism activities, port and marine establishments, and some extent aquatic culture facilities. In the Eastern Agency, we have too much facilities. I think nutrient pollution, eutrophication occurs. In the industrial, as for the industrial activities, there is a large range of different industrial activities scattered all around the Turkish coast. These hotspots are concentrated mainly on Ali Ağa, Nemrut, and Izmir bays in the western coast of Turkey, with large industrial complexes and commercial harbors. Pressures from industry include primarily the chemical and petrochemical and metallurgy sectors. In this map, you see the Eastern Aegean coast, Izmir Bay, and Çandarlı Bay here. Izmir Bay is a metropolitan city. It is densely populated. Industrial facilities exist there, and the north of the second red circle, Ali Ağa, situated there. Rivers of Turkey, Aegean Sea, in the Aegean Sea, there are 5 rivers, and one of them, called Gediz, Gediz and Meriç, is the greatest, and dilute very high pollutants to the sea. Organic pollutants in the Eastern Aegean Sea. The marine environment of Turkey has been seriously affected by oil spills, garbage dumping, metal accumulations, PS, PCBs, and OCPS. Organic pollutants, the production and use of many fluorinated compounds were completely banned in Turkey in the 19th. However, total pesticide usage in 1995 was 37,000 tons, and this has shown a steady increase year after year. The PCBs continued to imported and used illegally until 2000s. According to the established guidelines for sediment quality, the risk of adverse biological effects from levels of OCPS and PCBs are, as recorded at most of the sites, was insignificant, but the highest concentration in Izmir Bay in the Gediz River estuary could cause biological damage. These are the studies on organic pollutants. I divided them into 2 parts, in sediments and biota, in this presentation. We started with sediments. This is my PhD thesis. In the Eastern Aegean Sea, sedimentary hydrocarbon consists of mixtures of compounds from natural and anthropogenic sources. Our findings indicated that the sediments from the entire sampling site, except Izmir Inner Bay, should have no potential biological impact as we expected it to be. This is the map of our study area. You see the stations here, and these levels are maximum in Izmir metropolitan city. pH concentrations, you see. At the same time, we research the organochlorinated pesticides and PCBs in the same area. Ddt contamination was not from this study. We concluded that Ddt contamination was not highlighted as a contemporary and ubiquitous problem in the Eastern Aegean Sea. Based on the sediment quality guidelines, DDTs and heptachlor would be more concerned for the ecotoxicological risk in the eastern aging coast. As for PCB concentrations, the sediments at Çandarlı, which has petrochemical industry and establishments, and Izmir inner base could potentially cause acute biological impairment. We decided these conclusions by sediment quality guidelines, EPIC range law and other values. This is the distribution of total OCP concentrations along the eastern aging coast on the map. You see here total OCP concentrations, which is very dense in Izmir Bay and relatively in Çandarlı Bay. This figure shows the EPIC range law value and TL values. Izmir Inner Bay, Çandarlı Bay exceeded these values. In another work from the Eastern Agency, Çandarlı Gap, we call Çandarlı Gap, the highest anthropogenic hydrocarbon inputs were found near the refinery and petrochemical industry. Maximum concentrations of PCBs were found near the petrochemical industry and were high enough to cause adverse biological effects at most of the sites. We also, in biota, the second part, biota, organic pollutants in biota, we measured methyl mercury, tributyltin compounds in biota, fish, barnacles, and other organisms. It was also shown that Diplotus annularis daily would accept permissible tolerable weekly intake for methyl mercury, which is a very important emerging contaminant. Though dibutyltin and monobutyllin in barnacles, mussels, and fish along the eastern aging coastline were not elevated, 7 out of 15 fish samples displayed total levels above recommended limits. In another study, Küçük Sezgin et al. Evaluated dibutyltin and monobutyllin levels in barnacles, mussels, and fish along the eastern aging coastline. The highest concentrations of these compounds were observed in barnacles, which had been sampled in marinas and harbors. Barnacles have high potential as biomonitors for the presence of organotin in the Aegean Sea. These are our conclusions from these investigations. The consumption of blue crab in a other study, blue crab, gray mullet, and annular cymbeline from the Mediterranean coast of Turkey would pose no risk in 2017. These studies are in chronological order. In a study in 2018, organochlorines were measured in 2 species, Mullus barbatus and Diplotus annularis, collected from Izmir Bay during 2009 and 2012 to explain the status of these contaminants in edible fish. The potential risk for fish consumers were assessed. The estimated daily intake values for DDTs through the studied fish species by inhabitants of Izmir were much lower than the ADI established by the FAO, who indicating no relevant health risk through consumption of fish in the area on the west coast of Turkey. In a other study, 2020, it's very close to our date, paths were determined in the coastal region of Nemrut Bay, eastern region, sediment and cage mussels. This time we sampled cage mussels, were evaluated for 16 pH. I think 16 pH, you know, priority pollutants, we call them. High contamination was observed in the sediment sampling sites next to the petrochemical refinery. The assessment of human health risk based on the carcinogenic toxic equivalency suggested that the mussels have high capability to give rise to carcinogenic risks. pH levels in the mussels were above the recommended total carcinogenic pH limit set by the European Union. And the most recent work, the levels of petroleum hydrocarbons in marine aquaculture sediments from 3 different fish farms located on the eastern coast of agency were studied for assessing the quality status of aquaculture regions. The results concluded that the sediments from the aquaculture sites, except crabs, may not cause acute biological damage. This work by this institute is chronological order, and most recent ones we studied. We would always like to cooperate with you in workshops, projects, and training courses on emerging pollutants. Thank you.
Thank you very much for your presentation. Sea pollution is an important and serious issue in Turkey. Thank you very much for reminding us these important and serious issues once again to us. I believe that the effects of industrial activities on marine pollution is important, and we have to work on and we have to focus on these issues. Thanks once again for your presentation. I'd like to invite the next presenter. She is Dr. Güzel Yücel Ciğer. Before her presentation, I'd like to give you a brief information about her. She graduated from Hacettepe University, holds a master's degree in marine aquaculture from University of Caen, France. She was awarded a PhD in aquaculture from Istanbul University. In early career, over a period of 15 years, she had hands-on experience in the foundation, ownership, and management of hatchery, nursery production units in Izmir. Eventually, she set up hatchery business. Later, she was appointed technical director of the new aquaculture projects department of the Turkish Agriculture Bank, and she was responsible for assessing the viability of fish farms in all parts of Turkey. Dr. Ciğer has been a researcher in the Marine Living Resources Program in the Institute of Marine Sciences and Technology of Dokuz University since 1998. In the field of sustainable management of marine resources, she focused on ecosystem approach to management, on carrying capacity modeling, on environment interactions with marine aquaculture, and on its integration into coastal zone management. Dr. Ciğer is working also on the wetland and mapping of benthic habitat as Posidonia oceanica in Izmir Bay. She contributed to many national and international projects, has published widely, and has organized many conferences and workshops. Dr. Ciğer participated in international work groups on marine ecosystems. Dr. Ciğer, it is a great pleasure for me to invite you to start your presentation, please. We cannot hear you, Dr. Ciğer.
Okay, thank you. Thank you for your invitation. It is a very interesting meeting. Now I want to presented mapping of Posidonia oceanica. It was the project, and we realized this project with all name which you can see. And this is the project continued 3 years, nearly 3 years. And this is the mapping of Posidonia oceanica in the Bay of Brunei. This also bay is placed in Izmir. I continue about well, yes. This is the overview of my presentation: background, aim of study, material, method, result, and conclusion. The background, I tell you the background of the project. These meadows, we have the meadows in Mediterranean, live at depths between 0 to 40 meters. Posidonia helps prevent coastal erosion, and it is important source of oxygen, and it is habitat for marine life. But rapidly increasing tourism, fish farms, fisheries, construction on the coastline, and waste from this activity is damaging this fragile ecosystem. Due to increase in light intensity and coastal development and sediment loading, seagrass distribution has declined. The aim of this project and this study was to accurately map the destruction of the coastal region and keep pace with the environmental changes. What is our material methods? To achieve this, we used the scan sonar, sub-bottom profile, and world view satellite image techniques. I will talk a little bit about our study area. This is the Mediterranean, this is the Black Sea, and this is the Aegean Sea. We are here. Our colleague present recently, Tolga, it is Izmir city, and we have the Izmir Bay. In the Izmir Bay, we have the Gulbahçe Bay. This is the Aegean Sea. This is Greece. This is the Turkey. And this study area, 58 square kilometers in the Gulbahçe, and the depth 1 to 30 meters sea depth, where it's present Posidonia. The widespread availability of Posidonia is particularly important in terms of nursery grounds for many commercial couch species. In the study area here, the number of, there are 3 fishery cooperative and 220 people make living from relation profession. This area is very fruitful because of this Posidonia. This is a previous study. In this previous study, we identified 3 types of Posidonia: tiger, here you can see tiger, reef here, and also atoll Posidonia. One of the most important reasons we work in this area, because in Mediterranean, you can see Posidonia oceanica in this type of habitat or atoll or reef. In this area, you can find 3 different forms in the same area. It's why we choose this area to making the mapping. The bay in its surrounding were viewed on the Google Earth 2012. We use firstly Google Earth map, and control classification was performed using the above mentioned image. Before starting classification process, the control groups at different locations were visually selected on the image satellite like this, and we see you can see here, you can see Posidonia already here. This location were visited an expert and direct to verify the control group. This is the previous study. And after we started the project, in the processing of image is as follows. I will talk about Geo Referencing, the method we use to monitor the bay. The first step we took to monitor the bay was capture Geo Referencing image. This is the first step of our project. This is the georeference our satellite image by using the points and coordinates taken from the Google Earth. The accuracy mean square is approximately 3 meters. First, we had a look at the satellite image and we decided where to dive, and in order to be accurate, we entered the exact coordinate from the satellite image. This is the satellite image and we look at where we are going to that. And the exact coordinate from the satellite image to our health GPS. Before starting the classification process, the control at different location, there are different locations in this area, we were usually selected on satellite area. This location were visited an expert dive to verify the control class. And this is the, our field work and the data collection. This is the Posidonia oceanica. Some photo from dive. On the left, you can see also a shoot of the Posidonia. The boundary of Posidonia and other attributes like sand, mud, Cimodocea were first identified in the satellite image. In this work, we don't do only Posidonia oceanica, but we also classify legend, Cimodocea, sand, and mud, because also had the boundary of Posidonia and other attributes. Their coordinates were uploaded to GPS. We search for this location in the sea. We also included other points in the field when necessary, because sometimes we find another interesting point. GoPro image taken during this study, we use a lot. At the beginning, you see we tried photography in the sea, but it is so difficult. Finally, we decided to use GoPro image. A GoPro image is taken during the study. The first photo shows dance. It's the healthy Posidonia. Photo 2 shows sporadic signs of Posidonia between die and it's not healthy Posidonia. Photo 3 shows no signs of Posidonia, just mud. This slide indicates the sampling points in the bay. Rows in green indicate action camera location. Pink indicates scuba diving location. We take the sample 926 sampling, the photo in this area. And then the data was transferred to Excel file. You can see here the date, the number, we use sometimes snorkel, GoPro, the coordinate, and explanation here. Posidonia, no Posidonia, mud, all the data. 3-step transferring image to the ENVI program. E, masking of land. this is the masking of land you can see here. This is the step of masking of image. And here defining polygon also. Here you can, we use two classification, one's ML and others CV methods. You can see identification of polygon. This is a light color training data used for classification. Dark color testing data are used to check the accuracy of classification. This is the identification of polygon. And filtering here, classification map obtain, we use the ANVI program and our raster in size and the isolation pixel. And this is the, using the ANVI program and classification with two different classifications. This is the result after the filtration. And some of the legends, it was very good. One, for example, maximum likelihood. For others, for example, for the sand, it was a support vector machine, it was good. And this is the satellite image we use it for the mapping. In other, in our project, in other also complementary using the scan sonar data. Also other experts, they work in other vessel and using high separation seismic profile and lateral scanning sonar, you can see, and we use the vessel, the fishery vessel. And here you can see lateral scanning sonar mosaic image and sea meadow borders. We work north and south and west and east. We devised the Gülbahçe Bay are 250 grid, and we work here. And this is the results, some of the image. Here you can see scanning sonar. This is the Posidonia, you can see. And this is the boundary. And this is the sand and mud using side sonar data. And then this is the depth of Gülbahçe down the 30 meters. After a satellite image and sonar, it was necessary to scuba dive to confirm the reading from the side scan sonar also. And the conclusion, finally, this is the Gülbahçe Bay. And this is the green Posidonia oceanica, the red mud, legend, yellow sand, and the pink color is Simodocera, and hard bottom is gray. And finally, in this result of this project, Posidonia spread of the meadows is more intense in the west of Gülbahçe, while the spread depth of meadows was found to be limited to 12 to 15 meters in general. It was observed the border of Posidonia oceanica reached 20 meters, but very one places we see this. And this study shows the boundary of Posidonia in this area, 4,000 hectare, 1,400 hectare, means 24% of the entire bay area. At the beginning, this project, it was important because they are the fishermen cooperative. They asked our institute to make this kind of the map because they know Posidonia oceanica is a very important habitat for the fishery. And this is the one important result for them, this mapping. And other also, we make our site the publication about this study, this project to publication. And thank you for listening. Thank you so much.
Dr. Jer, thank you very much for your very interesting presentation about Posidonia oceanica. We came to final presentation. The final presentation will be done by İlham bin Halil. Before his presentation, I'd like to give you brief information about him. He is currently a senior lecturer in Marine Science Program, Faculty of Science and Marine Environment, University of Malaysia, Terengganu. He earned his bachelor degree on marine science from the University of Putra, Malaysia, and master degree in Geo Information Science and Earth Observation for Environmental Modeling and Management from University of Southampton, United Kingdom. He worked as research officer at Malaysian Center for Remote Sensing from 1997 to 2008. His special focus and research are in remote sensing and geographical information system. Dr. Halil, may I invite you to start your presentation, please?
Thank you very much, Mr. Moderator, INOC Director, professors, colleagues, ladies and gentlemen. I'm Ilham Khalil, a senior lecturer in Marine Science Program, Faculty of Science and Marine Environment, UMT. I have over 15 plus years of experience in this amazing remote sensing and GIS field. First, I would like to thank the organizer, INOC, Institute of Marine Science and Technology, Dr. Ilul University, for the invitation and opportunity to share our experience here in UMT in dealing with coral mapping using drones. Some people may call it UAV or unmanned aerial vehicles. So let's start. So the first questions that we need to ask ourselves is how long does it take to survey coral reefs? A small study done by a group of Malaysians in Pulau Tioman in Pahang. It took them 32 days to finish surveying the coral reefs. The island is roughly around 56 kilometer shoreline length. So it took them almost a month to finish the coral survey. So in Malaysia, we have 42 marine parks that have been gazetted to safeguard our marine biodiversity in our waters. So just imagine how long it will take us to finish surveying or mapping all the coral reefs around our country. For today's talk, I will focus only a small area in nearby to the Dr. Saifullah sites just now, a place called Labuan Marine Park here. All right, so if the conventional technique is would take us a very long time. So the second question would be, can we monitor coral reefs from space, right? The answer is yes. I give one example here. This is the mapping of coral reefs in South China Sea using a 3-meter spatial resolution dove satellite. So A is basically the satellite image of an atoll coral reefs. B, just to show where basically the in situ or the sites verifications. C and D is are basically the classification or maps of the corals. So we can clearly see that the images can be classified into deep reef, coral rubble, sand, seagrass, and reef. Also shallow reef 1, 2, 3, and 4. All right. So, but in reality, because of Malaysia, we are close to the equator. We have this kind of satellite images all year round. We have very high cloud cover that I would say mapping exercise using satellite image could be hampered when cloud cover limits the image availability. So that's why I think we began looking at the possibilities of using drone for coral mapping way back in 2017. So it was not a one-man show business. The research was conducted together with Department of Fisheries Malaysia, National Hydrographic Center, and University Technology Malaysia. Each agency and each institution plays a major role in this project. So in theory, spectral reflectance of corals is a fundamental parameter to coral reef remote sensing. We use these informations to map out the types and size of the corals. For those who are not very familiar about this reflectance curve, what I can say is each curve represents different types of coral life forms. For example, the blue one is basically massive non-acropora or massive life forms, this one. And then the branching acropora is the red one, and also this is the tabulate acropora. So as long as the spectral reflectance curve doesn't overlap each other, basically in theory, we can differentiate or we can classify the corals or the substrates based on spectral reflectance. So that's the idea, the main idea. All right, so this is the overall workflow of our projects. We put two sensors. The first one is multispectral sensors, and the second one is the normal RGB camera, Zenmuse camera, and this one is the multispectral camera or Mica sense sensor. We put both on board our DJI Matrix 100, right? And then after get the images, the photos, we run the standard procedures, correction and pre-processing of the images, and then we run the pixel-based classification. At that time, we only use the standard maximum likelihood supervised classification. We don't even have time to go for SVM yet. And then we also have ground truth team that went to the ground checking the real life form over there and even go until species level. So combining those two inputs from the drones and also the ground team, we can come out with the coral classification maps and also benthic habitat maps. All right. So this is the example of all the single drone images, right? We combine all the images and then we mosaic it, and then we proceed with the classification, coral reef map classification. We can also get the digital surface model because when we fly the drones, basically the overlapping is 60 to 80% depending on the orientation. So, but for the purpose of this today's presentation, I will not share about the digital surface model. I will only focus on the classification of the coral maps. Right. The classification scheme that we use basically is modified and adapted from NOAA 2005 and Stefan et al. 2016. We have three levels of classification. The level one, we just want to know which area is coral and which area is non-coral. Level two, a bit details. We want to see if it is non-coral, then can we differentiate that coral, algae, sand, rock, silt, and other. And the third one, which is more details, we classify the non-coral into that coral with rubble, that coral with macroalgae, sand, submerged rocks, sandglean, or waves, and identify unidentified objects or features. And then we try to have a look, is it possible for drone images to categorize coral based on their life forms. So the general life forms that we are interested is tabular, branching, massive, and aggregated patch reef. So this is the example of pictures or photos from our ground team or the diving team and the snorkeling team. So this is the branching coral, massive coral, tabular coral, and aggregated patch reef. All right, so in total, we got 34,146 6 images that need to be processed, need to be mosaic, and then after that we need to come up with the classification. Bear in mind that each MicaSense photos consists of 5 bands. So just multiply that by 7411, 6386, and so on. So we have huge amount of data set basically. Each yellow dots here represent one snapshot of the drone image. We have covered 3 islands in Labuan Marine Park, Rusukan Besar, Rusukan Kecil, and Pulau Kuraman. Right, challenges. What are difficulties that we face in the project? The first one in the box A. So we get poor mosaic because whenever we do a mapping in waters, in shallow waters, it's not as easy as we do mapping in terrestrial area, because it's very hard to get matching points in the waters due to so many factors: turbidity, quality of the water, water columns, and all that. So it's very hard to get the matching points, and then so it will produce poor mosaic. Second one, turbid water. As you can see here, we wait 3 days to fly in this area, right? And suddenly it was raining about half an hour, I think, and there is rivers basically going through the sea, and this is all what we get: very turbid water, and we cannot see the coral. The only clear images that we get is in Pulau Rusukan Kecil, a very nice photo, 5 centimeter spatial resolution, and bear in mind that we have 5 bands, right? And this is the Rusukan Besar. We can see that even the bottom of it is very clear water at that time. All right. So based on a few years of experience, I would like to share with our colleagues in Turkey that we really recommend that this kind of study to be conducted during neap tide, because we get clear water. And please in our region, we have to start working early from 7 until 9. Above 9 in the morning, then we get this one. Very nice sun gleam, but we get very frustrated when we see sun gleam in our images, because we cannot see anything down there, right? And of course, please choose a very not a windy day to fly your drone. We have several cases, because when we send our drone from the shoreline, it's about half a kilometer. So it's very risky, because we have our multispectral sensor on board, which costs us about 20-30,000 ringgit Malaysia just for the sensor, not including the drone itself. All right. So our ground truth team went to 159 stations to do the verification all over the islands, right? This is all the points. So basically, we do the spot check either by snorkeling or by scuba diving, depending on the depth of the water. Right. Coming to the result section, the first classification, level 1. So the pink color is basically the coral area, and the green color is basically non-coral, right? So we can easily see here that we can estimate, or we can calculate the area. So live coral is basically around 20% of the whole area. So this kind of information is very helpful for marine managers or marine park authority to make decision. So this will help them. And the second level result is much more interesting, because you can see the live coral, dead coral, algae, sand, rock, and silt. We combine these three because as the previous professors mentioned, sometimes we do have mixed classes in our image classification. So to deal with that, we need to basically to filter out and some other alternative methods. But because this is the first our first project, so we run it on the basic classification first, right? And then the third level of classification, we can see here clearly that drone images, okay, can classify the life forms. So here we get 2.2% of massive coral, 25% of dead coral, 6.11% of branching coral, and 1.66% of tabular coral, and 44.58% is submerged rocks. So this kind of information would really help managers to quantify, translate this information into economic, into numbers, because people now is always asking for numbers in terms of budget preparation and all that. So Marine Park Department is very happy with this project, and then we conduct the project to 3 islands, another islands, but due to the pandemic, we need to put on hold the project. So we are really hoping that the pandemic is over so that we can continue our works. Right. So in terms of accuracy, as I mentioned earlier, we test 2 sensors. The first one is the RGB camera, the standard one using by the drones, and the second one is the Mica Sense multispectral sensors. So the accuracy for Zenmuse or RGB camera is almost 70% accuracy, and the Mica Sense is 75% accuracy. So depending on your budget, basically, you can decide whether you want to go to multispectral sensors or use the standard Zenmuse sensor. All right, this is the kappa statistic for those who want to have a very detailed looks after this. Right, so before I end, I would like to introduce our team that have been working very hard in this project. Prof ID, basically the project leader, myself, Dr. Shaukat, and Dr. Ifan is focused on the image processing in the project. And Prof Zainuddin is basically our marine ecologist expert in UMT. He's leading the in situ team, scuba diving and snorkeling team. All right, and we have 2 anchor person here, Azam and Zul Kamal, our 2 pilots of the drones. Right. So in terms of publication, we produced until now 4 publications. Please feel free to have a look at the publication in remote sensing and GeoCarto, and then 2 other publications also in GeoCarto. Right, so in conclusions, I can say that the study has demonstrated that drones are able to reliably map coral reefs area. As associated technologies improve access to high quality information, they will continue to be critical source of information to reef managers, scientists, and conservationists. So with that, ladies and gentlemen, before I end, I share a quote from William James. We are like islands in the sea, separate on the surface, but connected on the deep. So with that, ladies and gentlemen, I end my presentation. Thank you.
Ilham Halil, thank you very much for your very interesting presentation, especially about remote sensing and geographical information system. I believe that we can learn lots of things about these issues later on. So we came to the end of this event. First of all, I would like to thank all presenters for their scientific presentations. I believe that these presentations, experiences will contribute to further researches and collaboration between 2 countries. As INOC, we would be more than happy to support possible research projects between 2 countries. INOC will continue to organize this kind of scientific events, workshops, and educational activities. Unfortunately, we don't have enough time for questions and answers section because of the limitation of time. But you can directly, I would like to inform participants that you can directly contact with each presenters for your questions and to get your answers. For the next INOC events, I strongly suggest you to keep visiting INOC official web page for further collaboration. Dr. Ong, would you like to say something on behalf of University of Malaysia, Terengganu No?
Thank you, Prof, for inviting us to join this seminar. I think in this room, I think we have Dato' Noraini, right? Can we have Dato' Noraini to say something? Yeah. Dato' Noraini is our head of cluster of our research group.
Okay.
Can unmute. Okay. Hello, Dato'. Host to allow.
Hello.
Me. Okay.
Hello, Assalamualaikum warahmatullahi wabarakatuh.
Alaikum salam.
Yeah, I'm very pleased together with all the other parties from Turkey and from Malaysia. I think both parties.
We cannot hear you.
Hello. Yeah, I'm back. Hello.
Yes, we are
Yeah.
hearing you now.
I think the video, somebody has to let me open my video. And the host, please open.
Sinem hocam, kamera izni verebilir misiniz?
Okay, so I'm back here. Thank you very much. I think it's a great pleasure to have both parties actually presenting their expertise. And then the topic actually covered almost very similar strengths in terms of what we can do next. Yeah, my name is Noraini Haji Mukhtar. As shown just now, I'm the head of the cluster, and I was formerly the vice chancellor until April. Yeah, but I believe this is a good beginning. Yeah, Professor Shermaine, Professor Bulan, and the rest of the experts from both parties, from UMT as well as from Turkey, from your institution. I believe we can work further on in terms of research collaboration, basically because of the need at the moment in the global agenda to enhance the capacity, yeah, in marine science research, particularly with the UN Decade of Ocean Science. Yeah, remember under the IOC of UNESCO is a decade of ocean science which needs observation, and we need to have a clean and healthy ocean. Yeah, and then the later one is actually talking about mapping the resources that we have. At the same time, we need to plan. So marine spatial planning is very high in the agenda. All countries how to plan without having to have conflicts of use. So I believe there are a lot more to discover from each other, especially from the joint publication, comparative studies. I welcome, and I'm glad, and congratulations to all. Thank you.
I totally agree with you. Dr. Shermaine Açıkçınar will definitely contact with you about further researchers on this marine sciences. So thank you very much for accepting our invitation and giving these speeches for us and for Islamic countries. So I would like to officially close the event and hope to see you in other marine science events. Thank you once again. Bye-bye.